Hi everybody, Mrs. Pesic here. We are going to continue our look at quadratic functions. We are looking at vertex form this time. So let's do that. Vertex form is y equals a times x minus h quantity squared plus k. And we had already looked at standard form. Now we're going to look at vertex form. And don't forget there really is one other form that we may look at, and that is intercept form. But for right now, we're looking at vertex form. Quadratic functions in vertex form, y equals a times x minus h quantity squared plus k. The vertex of the parabola is going to be h comma k, where the h is the number being subtracted from the x, and k is the number that's just hanging around on the outside. Alright, this should feel very familiar to you, like absolute value graphs that we were just talking about, because in those we had y equals a times absolute value of x minus h plus k, and the vertex was hk. So it's very similar, just absolute value or squaring something. So let's take a look at this example. What is the vertex of this? 3 times x plus 2 quantity squared plus 5, and the answer to that is negative 2, 5, because negative 2 is the number being subtracted from the x itself. So in other words, we could have rewritten this x plus 2 here as, so the vertex is negative 2, 5, and the reason it's negative 2, 5 is because what number is being subtracted from the x? Well, if it's x plus 2, that means we must have been subtracting a negative 2, because x minus a negative 2 would give us x plus 2. So the h here is equal to negative 2, and the k value is just 5. Alright, and what about the y-intercept? Is the y-intercept of this equation equal to 5? So here's our equation. And we're wondering, is the y-intercept equal to 5? Well, in standard form, it's just that number that's hanging out at the end. But so let's say, what is it? Yes? No? Try again. The answer is no. But what is the y-intercept? Well, to find the y-intercept, remember, that means we need to plug in 0 for x. So if we're trying to find the y-intercept, we can plug in 0 for x. And so we will have y equals 3 times 0 plus 2 quantity squared plus 5. And if we evaluate that, 0 plus 2 is 2, squared is 4, so that looks like 3 times 4 plus 5. I'm guessing then that we would have 12 plus 15 gives us 27. So I think that is going to be our y. That's going to be our y-intercept. So 27 is our y-intercept. Alright, so here's the key concept for our vertex form of a quadratic function. So let's take a look at this. Again, vertex form is y equals a times x minus h quantity squared plus k. And the graph is going to be a parabola. And it's going to be of this same family, ax squared, but it's going to be translated horizontally h units and vertically k units. So what are some of the characteristics of our graph? Well, the vertex no longer going to be here at 0, 0. The vertex has been shifted h units to the right and k units up. So the vertex is going to be here at hk. And the axis of symmetry is going to be x equals h, and so that's going to be a vertical line that goes right through the vertex. And we also have, in addition to that line of symmetry, we can tell whether the graph opens up or down, again, if that leading coefficient a is positive or negative. So there's the a value right there that we would be looking for. Alright, so what would be the vertex of y equals negative 2 x minus 4 quantity squared minus 6? So you are looking to say, what is my h comma k? So the h comma k is going to be 4, negative 6, because what's being subtracted from the x is 4, and what's hanging around on the outside is negative 6. So the vertex here is going to be 4, negative 6. What about the y-intercept? If we want the y-intercept, remember that means we need to plug in 0 for x. So if we take our equation and we plug in 0 for x, we would get y equals negative 2 times 0 minus 4. We would have y equals negative 2 times 0 minus 4 quantity squared minus 6. And if we want to simplify that, 0 minus 4 is a negative 4, but when squared is a positive 16. So we have negative 2 times 16 minus 6. So that's a negative 32 minus 6 is a negative 38. And that is going to be our y-intercept, and that's our y-intercept. Let's say we wanted to sketch the graph of a different function, f of x equaling 3 times x plus 2 quantity squared minus 1. We would start off by identifying, does it open up or down? In this case, it opens up because our leading coefficient is 3, and that's a positive number. Next thing we would want to do is we would want to find the vertex. The vertex, remember, is your h, k. So the vertex is what we want to find next, and the vertex is the form h, k. What number is being subtracted from the x? Or another way to look at this is, what number would I need to plug in for x to get this parentheses here to equal 0? I would need to plug in negative 2 for the x, because negative 2 plus 2 would give me 0. So negative 2 is really our h. So that's another way of thinking about it. What about the k value? That's the number that's hanging around on the outside, and that's the negative 1. So our vertex is going to be negative 2, negative 1. So I'm going to place that vertex right here. There's negative 2, negative 1. I know my parabola opens up. My next step would be to find the y-intercept. So let's do that. The y-intercept, remember, to find that, we're going to plug in 0 for x. So we would get y equals 3 times 0 plus 2 quantity squared minus 1. 0 plus 2 is 2. Squared is 4. Remember, we do exponents before multiplication, so we have to get that 4 first, then multiply by the 3, and then subtract 1. So to me, it's looking like this is going to be 11. So the y-intercept is going to be, so we get 11. That's a little bit off my graph, but I'm going to say it's about here on my graph as my y-intercept. We could also point out what is the axis of symmetry. The axis of symmetry is going to be a vertical line, so it's going to be x equals some number. And to find that number, it's always going to be the x coordinate of our vertex. So it's going to be x equals negative 2. All right? And x equals negative 2 is this vertical line right here that is going through our vertex. And so if we want to find the symmetry point, as we discussed last time, how far over do you need to go from your y-intercept to get to the axis of symmetry? That's 2 units. So we need to go 2 units past that, which would put us right about here. And so we have that. And let's plot 2 additional points just to fill this graph in a little bit more. And in order to do that, we would we would plug in 2 other values, like negative 1 and negative 3. So let's plug those into the equation and see what we get. What is f of negative 1? F of negative 1 would be 3 times negative 1 plus 2 squared minus 1, and then that would be 3 times 1 squared minus 1. 1 squared is 1 times 3. I get 3 minus 1 is 2. And so I can plot that. Negative 1, 2 is going to be right here. And I think I'm going to predict that negative 3 is going to also go to 2, but we can check that. So if I try to find f of -3, we get 3 times -3 plus 2 quantity squared minus 1. And so if we're evaluating that, that's a -1 in here, but squared is going to give us a +1. We're going to multiply that by 3 and subtract 1. So that's 2 minus 1 is, 3 minus 1 is 2. And so yes, we do have this point at -3, 2. And now we can draw in our parabola. Okay, yeah, that's really crooked, but that's the best I can do on my little pen pad, so forgive me for that. Okay, so let's take a look at how we would go about graphing these on the calculator. I don't think we've done any graphs on the calculator yet, so what you want to do is you want to go to the home page and you're going to choose graphing, which is this second icon here, so you can click on that. And it says add graphs to a new document. And so let's try and graph a function like f of x equaling 3 times the quantity. So I can say left parentheses. Here's where you're going to find the x right down here. And let's say x minus 2, close parentheses, and we want that squared. And so let's take a look at that graph. I push enter, and there it is. This is f of x equaling 3 times x minus 2 squared. Notice it's skinnier than the parent function. Let's get the parent function up here too. So to get another equation line, we would just do Control and G. That brings up another equation line for us to type in. And let's just do x squared. Here's our parent function. So that's our parent function, and the one I did after that is narrower, as you can see, because of the 3, and it has been shifted 2 units to the right. Let's do one more of these graphs. So bring back that function line again. So do Control G to bring the function line back up. Let's try -2 times the quantity of x plus 4 quantity squared, and then let's say plus 3. And when we graph that, we get this. Let's talk about why that's happening. By the way, you can kind of grab that with your mouse and your clicker and move that around. Let's see what's happening. The x plus 4 is shifting it 4 units to the left. The -2 is making it open down and is narrower, and the plus 3 is shifting the whole thing up 3. So we will look at this some more. I thank you for your attention, and we will talk more about this next time. I hope you took good notes and that you wrote down 3 questions on this video.